In this video, I'm going to talk more about intersections and union. I previously defined these in another video, so if you are not familiar with the basic definition, you need that as a prerequisite for this video. Let's start with intersections. In this example, I'm going to look at B intersect A. One thing I haven't emphasized much yet. So it is okay to say B intersect A or A intersect B. They both mean the same thing. So in this case, A and B actually have nothing in common. A is the numbers -5 through 0. B is the numbers 1 through 6. There's nothing in common, so this intersection is the empty set. The reason I did this example, even though the intersection is very simple, is because I want to introduce a new piece of terminology. If two sets, let's say E and F, have an intersection equal to the empty set, then they are called disjoint. So this is a new term that you need to know. In this case, A and B are disjoint, but A and C are not, and B and C are not. And I'm going to add a couple more sets into this mix. Let's have D be equal to multiples of 7. And we'll have E be the numbers 1 through 100. The reason I'm writing more sets here is because when I introduced intersection and union, I introduced it as an operation that can be done between two sets. We can find the intersection of two sets, the union of two sets, but we are allowed to intersect or union as many sets as we want to, as long as it's finite. You can do certain infinite unions and intersections as well, but we will not get into that right now. Let's consider B intersect C intersect E. There are two ways that we can do this. One is that you can do it by looking at all three sets at the same time, picking out the things that are in common between all three of the sets, and just writing it out that way. If that's a little too challenging, it is also okay to find the intersection of two of the sets, and then once you find that, intersect it with a third set. So I'll do this in both ways. First, I'm just going to intersect all three because I can see what this is going to be. So B just has the numbers 1 through 6, E has the numbers 1 through 100, and C has the even integers. What we're going to do is find the numbers that are in common with all three of these sets, and that's just going to be the even integers that are also between 1 and 6. So B intersect C intersect E is 2, 4, and 6. If you were looking at that and you're like, there's too many sets to think about right now, I want to just do it step by step, you can go ahead and look at B intersect C, or really any two of the sets, because again, it does not matter which order we write these sets in when we intersect them. But let's take B intersect C and just break down this problem piece by piece. B intersect C is going to be 2, 4, 6. And then if we're going to look at B intersect C intersect E, really we're just going to say, okay, what from the set 2, 4, 6 is also in E? The answer is that all of the numbers from the set 2, 4, 6 also lie in E. When we have a lot more than 2 or 3 sets, we do have a shorthand for writing the intersection, and this is going to look really strange. I will write it down and then I will talk about what it means. So the intersection of n sets, if those sets are named A1, A2 through AN, this is written either as A1 intersect A2 intersect ... intersect AN. So if you write it this way, you want to have an intersection symbol before and after the ellipses. But we can also write this in a more compact form as the intersection from I equals 1 to n of AI. An example of what this might look like is we'll have A1 be the numbers 1 through 100. We'll let A2 be the even numbers between 1 and 100. We'll let A3 be the multiples of 3 between 1 and 100. A4 will be the multiples of 4. Let's do A5 as well. So in this case, the intersection A1, A2, A3, A4, and A5, I could write this as the intersection from I equals 1 to 5 of AI. If you are solving this, you can look at this, give it some thought, maybe write down some notes, figure out what elements all of these are going to have in common, or you can break this up piece by piece and just look at a couple intersections at a time and then deal with it from there. So I'm going to do this in a non-linear fashion. I'm not going to just do like A1 intersect A2. I'm going to do it out of order. A, because it'll make things easier, and B, because I want to emphasize the fact that when we're talking about unions and intersections, we don't care what order we list them in unless we're mixing operations. A2 intersect A4. And the reason I'm doing this one is because A2 is completely contained in A4. So in the intersection, the only things that are going to survive are the multiples of 4. Now that we know what A2 intersect A4 is, we can rewrite this as A1 intersect A3 intersect A5 intersect A2 intersect A4. So just changed my order up. And then we know what this is, so we can rewrite this expression as. You don't have to keep breaking it down like this. It's just if you don't immediately see what the intersection is going to be, you are welcome to break it down like this. Now, A1 intersect A3 intersect A5, this is going to be the things that are multiples of 3 and 5. We end up with 15, 30, 45, 60, 75, and 90. And then A2 intersect A4 gave us the result of 4, 8, and so on. Now we want to look at these two sets and ask ourselves what they have in common. There are not a lot of elements left in this A1 intersect A3 intersect A5. So we're going to just look at that first set, 15, 30, 45, 60, 75, and 90, and figure out which things in that set are also in this set here, which is the multiples of 4. So the only thing that lives through this intersection process is 60. 60 is the only thing that remains. It's a multiple of 3, 5, 2, 1, and 4. So this is what the intersection evaluates to. I've jumped back up to the top of the page so that I can use these in examples of multiple unions as well. Of course, if we can intersect multiple sets at once, we can do the same with unions. A, union B, union the set containing 23, 24, 5, 7, and 9. And when we do the union, we're just going to take the elements from all three of these sets and just put them together. A is -5 through 0, and B is 1 through 6. So if we did A union B, we'd get -5, -4, ... all the way up to 6. If we look at this third set, the 5 is already accounted for. The 5 is already in the union of A and B, so we don't have to rewrite that. Put the 7 in there. Let's put the 9 in here, 23 and 24. Here we're going to talk about the union of n sets. We'll denote the sets A1, A2 through AN is either we can express it as A1 union, A2 union, ... union AN. And we can also represent this as, in this more compact form of I equals 1 to n of AI. Let's do an example. First, we need to choose some sets. Maybe we'll do B1 is equal to, we'll do it this way. We'll have B1 be 1 through 10. We'll let B2 be equal to, let's do 5 through 15, and we'll progress in this way. So 5 through 15. I do find that doing unions in general is a little bit easier to think about than intersections, because with intersections you have to ask yourself which elements are going to be in common with all of the sets that we're dealing with. But when you're doing a union, you're just taking all of the elements that are there and you're putting them into one single set. So I am going to do the union from I equals 1 to 4 of BI. We just take all of the elements that appear in all of these sets. And if you look through this list, you see that in total we have all of the numbers between 1 and 25. Another thing to know is that in this definition and in this example, I am starting at I equals 1, but we don't necessarily have to. I could say the union from I equals 2 to 4 of BI. And this would be the union of B2, B3, and B4. We don't need to start the bottom of any of these at 1. We can start at 2, we can start at any number we want, but then when we take the union, we just need to make sure that we start and end at the correct numbers. So B2 union B3 union B4 is B2 starts at 5, so we're left with the numbers 5 through 25. I will see you in the next video.
Dude, you slapped a fish. You punched it. Why would you hit it?
I wanted to make some seafood.
That's so loserly.